Hello Mindsetters, welcome to today's grade 11 maths show. Today we have a special revision lesson on finance and probability. We have selected highlights from lessons shown earlier in the term to help you revise this term's work. So please post your comments and your questions on our Facebook page or on Twitter @LearnExtra so we can help you with your revision. You can also download the show notes for today's lesson from learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with today's lesson.
So let's see what the first question is about. Thabo sells his business for 430,000 Rand when he is 32 years old. He then decides to save that money for his retirement. He deposits the money into a pension fund where the interest earned is 14% per annum, compounded annually. Calculate how much money he will have saved by the time he's 65, assuming that the money was invested for 33 years. So when you are first given the problem, you need to understand what the context of that problem is about. And so you need to read it just to establish, okay, who is it? What is happening? Okay, so from what we've read, we can see there's a person who's got a lump sum of money, puts it into a pension fund, and then leaves it there for an amount of time. So you get the broad context of that problem. Now you're going to dig deeper, and you're just going to read again to make sure that you extract the detail. So if we go back to it, we want to see, right, this now has got some mathematics attached to it. That's the p-value, number one. And he decides to save, he deposits the money into a pension fund, and the interest rate now is very, very important because the interest that's given is 14% per annum compounded annually. So this basically does two things. It tells us that we're going to use the compound formula, and number two, it's giving us an effective rate because it's giving us per annum compounded annually. So I don't have to work anything out because it's already an annual rate that's been compounded annually. So it's giving me the P, it's giving me the I, and it's also giving me that this money is going to be invested for 33 years. So I've been able to extract out of my formula those key three things in order to work out how much money he would have at the end of the investment. So my formula for compound interest, first of all, is 1 plus I to the n. Okay, and if I get all my values as I've done from the extracting of that context, then I know what my P is, I know what I is, I know what N is. So P was 430,000, and then I've got 1 plus my rate was 14% per annum, and then I would like to invest it for 33 years. So how much do I have at the end of that period? I have a little machine here that will be able to work it out for me. 30,000. Okay, maybe not. Okay. Let's try again. Okay, we'll need to get somebody to just look at our calculator and see why it's not working. So that would be my value if I multiply by that factor, which is 1,14 to the power of 33. So it's going to increase quite substantially. Maybe can you just ask somebody to tell me what's wrong with the calculator?
All
Thanks. Right. Now, what we're going to do, just to look at another effective rate, is to say, let's assume that this person was doing the same thing, but he was actually compounding monthly. So the same rate, but over a monthly period. How would that change? So Thabo stays the same, 430, but we're going to now say we want to compound that monthly. Okay, so I'm going to just add on Thabo's deposits same amount, and but at the interest rate of 14% per annum compounded monthly. and we'll say also over 33 years. How does that calculation change in relation to my new piece of information, which is this 14% per annum compounded monthly? Okay, firstly, if I'm going to be compounding monthly, just think about it. Every month, I'm going to be working out the new rate. So I'm not going to be giving you 14% per month. I'm going to give you a 12th of that. So it would be, our effective rate would be 14% every month. So I would take a 12th. So this would be per month compounded monthly. Alternatively, you could look at this rate in the following way. It's 14%, so it's 14% divided by 12. Okay? Or you could look at it as 1/12 of 14%, whichever way you like it. These are all the same thing. I'm taking 1/12 of 14%, so this will be my monthly rate, and this will be per month compounded monthly. So it's about just over 1% per month compounded monthly. So my I has changed, but over 33 years, I'm now calculating an interest rate that is a monthly rate. So my N is not going to be 33. It's going to have to be a value that is in months. So, in other words, since this rate is a monthly rate, okay, this becomes a monthly rate. Okay, all these are the same thing, it's a monthly rate. Then my N is now going to be in months. How many months are there in 33 years? So that would be 33 times 12. And we now have a new N and a new I. But the formula stays the same. It's A equals 430,000. 1 plus my new, whichever one you like, I like 14 over 1,200, to the new N, which is 33 times 12. And I can just use my calculator and see by how much has that changed. And in that way, we've been able to adjust the rate and the compounding periods. So just to summarize, if my rate was done per quarter, then my N would be in quarters. So there are 5 possibilities of being able to compound: annually, half-yearly, quarterly, monthly, or daily. And what you do to the rate, you must do to the compounding periods. So if I'm working with a quarterly rate, I must work with quarters. If I'm working with a monthly rate, I must work with number of months, etc. Make sure that the effective rate actually balances up with the number of compounding periods. We had a 430,000 grew to 32 million over 33 years. But wait, look what happened if you compounded monthly. It grew to 42 million. So it grew by another 10 million. So the idea is, if you're going to invest money, try and find an investment institution that will invest your money over every month, because it's actually the best rate is to actually get it over a month. I'm sure you can begin to imagine that if we did the same thing, but over a daily rate, I'm sure we would get much more. So isn't that exciting? The maths is speaking to you, and it's telling you, or it's empowering you how to make these decisions. We would like to have money being invested over a monthly period. Okay, so let's go on to the next question. Next slide. Right, we have a scenario. A car rental company buys a fleet of cars at a cost of 3.2 million rand. Calculate the, here's a word, the book value would be the resale value of the fleet of cars after 5 years if the depreciation is calculated at 6% per annum on a reducing balance. So we know that we've got a fleet of cars and they are worth a certain amount when we purchase them, and then they will reduce in value. They will not be as valuable as when we bought them. Okay, so we've got the context, a fleet of cars. Now let's go and dig for the mathematics that will be helpful. Firstly, we want to find the book value. Then we know that we want it after 5 years. And we're talking about depreciation, so we're going to see that the A value is going to decrease, and we have a calculation, a 16% per annum, and then we've got this word, a reducing balance. What does that mean? Reducing balance, is it simple interest or compound interest? Compound interest. So all these words are very important. That refers to compound interest, so it's reducing via that calculation. So we're going to look at fleet of cars, costs 3.2, depreciates for 5 years at 16% per annum. And we don't get an effective rate with depreciation. It's always an annual calculation on depreciation. Right, so let's look at that. We've got a fleet of cars that is 3.2 million. We have N is 5 years, and we've got I at 16% per annum. So we then use our formula, A equals 3.2 times 10 to the 6 multiplied by 1. Now am I going to put a plus or a minus if I depreciate? Okay, I'm not going to grow that value. I'm going to decrease it. So it's minus the 16 over 100 to the power of 5 years. And now I've got my magic machine, which hopefully this will work this time. So we've got 3.2 million multiplied by 1 minus 16 divided by 100. And we're going to raise it to the power of 5. What does that give us? The fleet of cars is now worth 1 million. Okay, so it was 3.2 million. It's now worth 1 million. So it's reduced almost by a third in value. So it's 1, 3. You can just write 1, 3 times 10 to the 6. So it's approximately that. I'm giving an approximation. In your final answer, they would actually want it to the nearest rand. So it would be 1,338,000. 1,338,278 rand. So that would be the worth of the fleet of cars. Now, any company would want to replace machinery, fleets of cars, trucks, whatever you're working with. We want to be able to replace them. And the next calculation is calculate the cost of replacing the cars at the end of 5 years if the price of the new cars is expected to escalate at a rate of 8.5. Now think about what's happening. 2014, we have a fleet of cars. It's worth 3.2. In 2019, 5 years from now, that car that we have purchased is going to decrease in value. But companies are continuing to make new cars. So the ones that are being made new for 2019, they will increase in value. So by the time we get to 2019, the ones that cost us now 3.2 are going to be costing us a lot more. So that's what this question is about. Calculate the price of the new cars if we're expecting an escalation of 8.5%, which is just slightly in South Africa over the inflation rate. So things are going to be going up by that value. And we're saying, well, let's have the worst case scenario 8.5. Hopefully it doesn't get to 10, because the higher that value is, the more that those cars are going to cost us. So we then have the situation. I want to know what are my cars which presently They cost me 3.2. Okay. What are they going to cost me in 5 years' time if my rate is 8.5% per annum, compounded annually? And they cost me this now. Every year they're going to go up by 8.5. So how much are they going to cost me in 5 years' time? 3.2 times 10 to the 6. And I'm going to increase it by 8.5 over 100 over 5 years. So what does our magic machine have to tell us about that? Okay, I still have that calculation in there. So let's just go back in. I want it over 5 years, and I want an 8.5. And I want to add this time around. So I'm going to have 1 plus, and it's an 8.5 that I'm dividing by 100. Let's see how much will the fleet of cars. Look how much it goes up by. That is 4.8 million, so it's almost 5 million rand in 5 years' time that they will cost. So that will be, no, not rands, equals, A equals. So we've got A will be equal to 4,811,701. That's how much the fleet of cars will be. Now, if you think about, because that's how far the question goes, but if you think about selling those the cars that you currently have and purchasing a new fleet, you actually have a difference of you back to 3 million. So by selling your old ones and purchasing new ones, you actually have a 3.2 million almost deficit, similar deficit as you had at the beginning. So Grey Levens, the whole idea around the finance is to be able to set up a sinking fund, a fund that you're actually saving into, so that by the time you get to 5 years later, you have the money to purchase and you don't have to take a loan. So that's the other aspect of this math that's very real. We're trying to save up for something that we want rather than getting loans, because paying back loans means that we're going to be paying for that debt as well at the same time. So we kind of pay double when we take out a loan. So the idea is, if you can work out how much your cars are worth, and if somebody can buy them from you, then you've got a little bit of money to pay as a deposit, so that the remainder of that money you have saved over time, so that you have the cash in hand and you don't have to get a loan, which is the ideal in this world that you're trying to aim at.
Okay, guys, I hope you're enjoying this revision session. If you are struggling and need help, please post on the page or send your questions to the Learn Extra Help Desk. The links are on our Facebook page. But now it's time to take a very quick break. Don't go away. We'll be right back. Welcome back from the break, guys. Doing revision is really important, so I hope you are enjoying this lesson. I'd love to chat to you on our Facebook page or on Twitter, so please let us know how you are doing. Enough of the chat, now it's time to get back to some more revision.
Right, let's look at what Kate's doing. Kate deposits 3.5 into an account. 3 years later, she adds another 4,000 to the account, and she's got an interest rate over the first 2 years at 8% per annum, and thereafter the interest rate changes. So we see, just from the context, something interesting happening. There's a girl, she deposits some money, she deposits another lump sum, but the interest rates have changed over that period. So we've got to accommodate for what's happening in that account. Okay, so let's read to extract the maths. So we have a deposit of 3.5, and 3 years later she adds 4,000. So here's some information that's quite useful. Then the interest rate for the first 2 years is 8% per annum, compounded monthly. Thereafter, the interest rate changes to 10% per annum, compounded half yearly. Calculate the value of the savings at the end of the 6th year. Okay, grade 11s, I think it's useful to always set up a little timeline that indicates the period over which we are working. So we make a deposit at T0, and then that takes me to the first year, to the second year, to the end of the third year, end of the fourth year, end of the fifth year, end of the sixth year. So we make a deposit of 3,500 Rand. And over these 2 years, this rate has been given to us as 8% per annum, compounded monthly. And after that, 3 years later, she places an amount over here of 4,000 Rand. And this rate over these 4 years is 10% per annum, compounded half yearly. Okay, so we've extracted all the maths, we've put in all the values that are useful for us. One deposit over that much, that deposit over that much, but the yellow period is monthly and the blue period is half yearly. So notice I don't have an effective rate. I first need an effective rate because I can already see it's per annum compounded monthly, and I can do nothing with that. So I'm going to quickly say that my effective rate here will be 8% is over 100, but it's going to be monthly, so it's going to be per month, compounded monthly. So this is now going to help me in my formula. And over here, it's half yearly. So if it's half yearly, it's 10%, 10 over 100, but I'm going to do it twice. So I want 10%, half yearly would be divided by 2, so it's 5% per half year. So that would be per half year, compounded half yearly. So that's what I'm going to be using in my formula. Okay, grade 11s, I want you to be able to break it up in your head and understand how the maths is working and how many calculations you would need. But I also want you to be able to construct your formula. Write it out, and then use one formula on your calculator. So if there's errors, you can go back and adjust it, because the calculator is quite constrained in its ability to delete and correct. And so you don't want to start all over again with your formula. So let's try and construct the formula. We have 3,500 Rand that stays in there for 2 years at that rate, so it's going to grow by that much. But after it's grown by that much, that becomes your new P. And that P is then going to grow at 10% per annum compounded half yearly. So we really are going to set up one formula that basically says this. My 3,000 Rand, actually I'm going to start with yellow, my 3,500 Rand is going to grow at 1 plus 8 over 1,200. Grade 11s, this is a monthly rate. Every month I'm getting this rate. How many periods will there be in my 2 years? There will be 24 periods. So I'll literally calculate first month, second month, third month, 24 times I'm going to work on this principle. And then my money stays in there. Now this becomes our new value. This A becomes our new P. And I'm going to grow that now 10% every half year. So it stays in there for 2 years, it stays in there for 4 years. So this becomes my new P, which I'm growing at 10% per half year. And grade 11s, how many half years are there in 4 years? There would be 8. So I'm going to calculate my interest 8 times. So that's how many periods there are. That's my half yearly rate. So see how I've constructed that formula to indicate that this is my new P. So I haven't gone into a new calculation and said A equals my new P from the calculator, and then I multiplied by that. Because the more values you're writing in, the more confusing it becomes. So try and construct it as one formula, understand what the formula is doing, and then punch it into your calculator. Much, much easier to do that. Because if you've then made a mistake, you can see it straight away. You want to know where the mistakes are going to occur. Here, have I got a monthly rate? Have I got the right number of periods? Have I got a half-yearly rate? Have I got the right number of half years? So you then can check that for accuracy, and you can go back to your calculator and just enter it. And notice, I haven't used my calculator at all because I'm trying to construct that formula. Now, I'm also going to add onto that, I'm going to add this little bit here that I've entered in my third year. So I'm going to add 4,000 onto that, and it's only going to grow at 10% half yearly. And how many half years? And we just double check that we've got this right. 3 years later. So 3 years later means I'm going to have 1, 2, 3 years to work with, and 3 half years, or 3 years, means that there are 6 half years, or 6 periods that I'm going to be compounding that for. Once I've got my formula, I can now go to my calculator, and we'll start with my 3,500 that I'm going to multiply into 1 plus 8 divided by 1,200, and that's to the power of 24. And then I'm going to multiply that by 1 plus 10 divided by 200. And that's all to the power of, let's come this way, 8. And then I'm going to add on my 4,000 and multiply it by 1 plus 10 divided by 200, which is to the power of 6. Power of 6, not coefficient of 6, eh? And I can now give an answer. Now, if I've made any incorrect thing here, I can go back and edit. I've got space there. So I've got 11,425 Rand at the end of that period. So A is equal to 11,000, already forgotten what it is, 425 Rand. Okay, now isn't that amazing? Over the 6 years, we had 7,500, which has grown to 11,425. And if you look at the calculation we did previously, we saw that if you do a monthly calculation, you earn more interest. So I'm not sure why she chose to do a half-yearly calculation, but that is the context that was given to us.
Okay, guys, I hope you are enjoying this revision session. If you are struggling and need help, please post on the page or send your questions to the Learn Extra Help Desk. The links are on our Facebook page. But now it's time to take a very quick break. Don't go away. We'll be right back. Welcome back from the break, guys. Doing revision is really important, so I hope you are enjoying this lesson. I'd love to chat to you on our Facebook page or on Twitter, so please let us know how you are doing. Enough of the chat, now it's time to get back to some more revision.
Okay, so grade 11s, you know me by now. We've been working together for the whole year. And what have I said to you about working with text? If a question's got text, what do? You read it 3 times. The first time you want to read so that you can understand where you are positioned. Where does this question position you? Where are we? What are we dealing with? The second time you read it again, you want to extract all the mathematical bits that are important to the context. And the third time you read it, you want to make sure that you've actually extracted the correct piece of information. So let's read the context. During summer in a certain city in South Africa, the probability of a sunny day and the probability of a rainy day is 3/7. If it is a sunny day, then the probability that Vusi cycles to work, the probability that Vusi drives to work, and the probability that Vusi takes the train. Okay, so we can stop there. We know we're talking about a city, and we're talking about whether it's rainy or not raining. So a rainy day or a dry day. And so it gives us all that information, and then it says, draw a tree diagram. Okay. So if we read again, we'll look, it's rainy, and Vusi's going to work by 3 modes of transport. So we have some choices to make. So choice 1, is it a rainy day or is it not a rainy day? If it's a rainy day, then Vusi's going to work with 3 modes of transport. If it's not rainy, he's also going to take those 3 modes of transport. So let's go back and now extract the maths. During summer in a certain city in South Africa, the probability of a sunny day is, and we've left that out, 4/7, and the probability of a rainy day is 3/7. So we have the choice of a sunny day or a rainy day. So we can already start with our tree diagram, and we can talk about our choice of whether we have a rainy day or a sunny day. So my sunny day has a probability of 4/7, and a rainy day has a probability of 3/7. So my choice of 2 days. Then, if it is sunny, then the probability that Vusi, he cycles, he drives, or he takes the train. And it gives me the probability of cycling, driving, and by train. So they're all there. So I can have choices. If it's sunny, then it can go those 3 ways. And if it's rainy, then it can also go those various ways. Okay. So I need to fill in on the branches what each of the probabilities is. So we have cycling 7/10, driving 1/5. So let's go cycling. Cycle. We've got driving and train. Drives and by train. And the cycling is 7/10, the driving is 1/5, and we're just extracting that information, and the train is 1/10. Then if it's rainy, he also cycles, he drives, and he goes by train. And those probabilities are, this time round, 1/9, 5/9, and 1/3. 1/9, 5/9, and 1/3. Right, I left you where we were in the middle of drawing that tree diagram, and just to get things nicely fitting on the screen, I've just redrawn it, and now let's answer the question. The question was, for a day selected at random, what is the probability that if it is a rainy day and Vusi will cycle to work? So probability that it will be a rainy day and Vusi will cycle to work. Notice the word and, so we are taking the probability of the rain and the cycle at the same time. So let's go to our tree diagram and let's just put that down. What is the probability, we use capital P, for a rainy day and a cyclist, and Vusi the cyclist? Okay. Which I think it's a little bit crazy, but anyway, he thinks that he can cycle in the rain. So what is the probability of that happening? Now, you would take the probability of the rain and you would then follow this branch. We don't want a sunny day, we've chosen a rainy day, and we want to choose the cycling route. So the probability when 2 events are independent, like this, is that you take, and I'm going to write it in white, that the probability of rain and cycling would be this 3/7 times the 1/9. Okay, and the probability of rain and driving would be 3/7 times 5/9. Why on earth is it doing crazy things like that? 3/7 times 5/9. And the probability of there being rain and Vusi riding the train would be 3/7 times 1/3. Okay, so just showing you how the different probabilities work. So our rain and our cycle would be our 3/7 times 1/9, which is 3/63. And then remember I said to you it's a value between 0 and 1. So if you wanted to really know what that value is, then you would just say 3 divided by 63, and we'd get a probability of 0,047, which is 48. So 0,48. So that would be equal to 0,048. We often take that to 3 decimal places, but do follow the instruction on the exam. Right, and then the last question is, what is the probability that Vusi would take a train to work? Okay, so now, if we were looking at the train situation, he takes the train here, and he takes the train there. So we have to consider the probability here, which would be a 4/7 times a 1/10, and this probability here. So there are two situations, two scenarios. It could be sunny and he takes the train. It could be rainy and he takes the train. So we would have the probability of taking the train. So we could say, if you wanted to be strictly correct here, that it would be a combination of sunny and the train together with rainy and the train. So we'd get this one here, we've got it up there, would be 4/7 times 1/10, 4/7 times 1/10, plus, because remember the or means we're adding the two options, would be our 3/7 times 1/3. So that would give us some values. If we just work it out here, of 4 divided by 70 plus 3 divided by 21. So that probability is a fifth. So it's 0,2. 0,2 probability of doing, of just riding that train, but doesn't matter what the day is. So that really works on the tree diagram. We always set up our options, and then we work with the independence of the events, and we then work with either an and or a or set. Okay, so that's really deals with one aspect of probability, which is to work with the various options that are given to us in terms of events. Now we'd like to look at a scenario where it's a lot more intricate and we need to think a little bit. So let's see what our second question is. Right, it comes from a previous paper. Okay, we've done that. So let's just see, did we miss some questions here? Okay, if we have time at the end, we'll come back to that one. Let's move on to this question here. Okay, it comes from last year's March paper, and previously this was found in paper 3. Now it's been brought into paper 1. A survey is conducted among 174 students, and we've got the following results. Okay, draw a Venn diagram to represent the information. Okay, so what often happens is when you do a survey, you've got things that are categorized into certain sets, if I can call it that, and we now want to demarcate how these sets are working. So again, we read the problem 3 times. We have the context, 174 students are surveyed, and so many study life science, so many study physical science, so many study mathematics, life science, maths, physical science. So it looks like people were chosen and they were asked about, do they take life science, do they take physical science, and do they take maths? Now, give me the possible options that can exist. If you ask person A, they can be a student that takes all 3. If you ask a person B, they can be a student that maybe take 2 of them. If you ask person C, that person may only take one of them. And if you ask person D, maybe that person takes none of them. So as you can see in a survey, you will be able to categorize the various people into specific sets. What we're going to do with the Venn diagrams is we always start with where all three would be happening. So you would want to count the people where they were all taking life science, physical science, and mathematics. And then we work our way out, because it's much easier to work out than it is to work into the problem. So tell me how many people choose life science, mathematics, and physical science, because that's really what the context is. So notice we've given a broad perspective of what exactly is happening in the survey. We now want to go and dig. We want to get the mathematics out. So let's go and do that. Okay, so since it is a Venn diagram, we're going to just ask the page to cooperate with us, and we're now going to try and use up the space as best we can. So we have a set, always drawing a rectangle to indicate the sample space. Do you remember how many students were interviewed? 174. So our sample space always goes on the outside. I want to know how many take life science, how many take physical science, and how many take mathematics. Okay, so this is my life science set, this is my physical science, and this is my mathematics. Notice that the people in the middle here are the people that take all three. They take all three subjects. The people in this branch here, some of them already take both, but these people here only take life science and physical science. These people here only take life science because there's no intersection with the physical science. These people here only take physical science, and these people here only take mathematics. So it is important to understand how those Venn diagrams are drawn and what information they give you. So who sits in the middle here? The person who takes all three subjects belongs to that set, belongs to this set, belongs to that set. What's happening to the people in here? In the set here, if I had to just work out what this yellow here is, this little branch. Those people only take life science and maths. They don't take the physical science. What about these people here? They only take physical science and maths. They don't take the life science. And these people here, they only take life science and physical science. They don't take maths. So what's left over is the people that only take the life science. So with a diagram like that, it's a powerful tool to visually capture what has taken us lots of time to actually collect. So let's look at the numbers now. So first of all, there's the context, and then the people outside the sample space, or not outside the sample space, but outside these diagrams are the ones that don't take any of those three subjects. So 37 study life science. We go back here. Where are those 37? They are inside the circle that represents life science. We don't know whether they're in here, whether they're in there, whether they're in there, whether they're in there. I just know that they're all inside here. So that doesn't give me enough information. Remember what I said just a moment ago? Where do we start? With the people in the middle. So let's go and find who should be in the middle. The 37 doesn't help me. I've got to go look for more information. Let's go look for more information. 60 study physical science. That still doesn't help me. 111 study mathematics. Still doesn't help me. 29 study life science and maths. Where are those people? Where are the life science maths people? Okay. They're inside the white and the yellow. So I know the total, but that doesn't help me because I don't know either of those two. So I'm still looking for more information. What do I want? The information that tells me where all three subjects are taken. So let's keep searching. 29 study life science, 50 study maths and physical science, 13 study physical science and life science. 45 do not study any of those subjects. Okay, we know where to put the 45. They're sitting out here. So these are the 45. That still doesn't tell me what's happening in the middle. Ex-students study life science, mathematics, and physical science. Ah, here's the magic. Here's the magic. what I was looking for. How many are taking all 3 subjects? And they've just given me that hint. They're saying to me, it is X number of people. Now, can you see earlier on they told me how many were in the white and the yellow? So now I can go back and look for the intersections of the 2 sets. I've got the intersection of 3. I can now do the intersection of 2. Let's go and look for all the intersections of the 2s. Where are they? Here we go. 29 study life science and maths. 50 study maths and physical science. And we've got 13 study physical science and life science. Okay, so let's work on those. Life science and maths, 29. Life science and maths, 29. So in here are my 29 that study those subjects. But I'm now including the X that are doing all 3. So how many should be written in the yellow? Okay, 29 is my total for the whole lot, but X already study all 3. So inside the yellow, I'm taking away the ones that study also the physical science and life science and maths. So inside the yellow, I only now have the ones that are studying both those subjects. Okay. 50 take maths and physical science. 50 take maths and physical science. So therefore, that's the total minus the ones that already take all 3. So in the end, I'm only going to get a value for the maths and the physical science. And then we have 13 study physical science and life science. So I have that one is 13 minus X. Okay, so look carefully at how we've worked from the middle and we've worked out. So we know how many were studying all 3. We've been now able to work out how many are studying 2. Then, what do I need to find out how many study just life science? Okay, now the beginning information is now useful because I've got 37 study life science. What does that mean? That there are 37 in the circle, the life science circle. That plus that plus that are already in there. So what must go in here? 37 minus 13 minus X minus X minus 29 minus X minus 50 minus X. So inside here, I've got the ones that are taking only life science. And if we do those calculations, minus X will become plus, minus X will become 0, plus X. So I'll be left with an X, and 13 and 29 are 42. So 37 minus 42 gives me minus 5. Then inside here, physical science, what are they telling me? They're saying that 60 study physical science. 60 study physical science. So if we go down here, it will be, in total, I've got 60. Now I've got to take away these that are studying 3 and 2s. So 60 minus 13 minus X minus X minus 29 minus X minus 50 minus X. Okay, so we've got, again, the plus X, and what have we got here? That's 42. Sorry, this is just the physical science. So the physical science doesn't include the 29 minus X. I was already adding that in unnecessarily. So that would be, okay, so 60 minus 50 would be 10, and 10 minus 13 would be negative 3. So that would be a negative 3. Right, and finally, how many are taking maths? I think there were 111, if I remember correctly. 111 study maths. So in this circle, there's 111. So we now have 111 minus the ones we've already got, 29 minus x, minus x, minus 50 minus x. So that's going to again be x, and we've got 29 plus 50 would give us 79. So 111 minus 79, 8, so that's 32. X plus 32 would be that. So we've been able to tell you exactly how many are just taking life science, maths, and physical science. Okay, the first question is to draw the Venn diagram. It's for 6 marks, all these little bits and pieces. Let's see what the second question is. Okay, same thing. And we now have show that x is 13. How are we going to show that x is 13 from all this? Is we go to our diagram and we say that those amounts, the individual amounts, all those amounts must add up to 174. And you solve for x. So it's as simple as solving that equation.
We've come to the end of today's show. Thanks for joining me and for chatting to me during the show. Please visit our website learn.mindset.co.za to get the notes and to watch the videos from earlier in the year. And remember, we are here to get you through the year, so stay connected. Goodbye.